So continuing the first section of Chapter 7 on the Introduction to Geometry, we're going to continue to define some things. We defined a point, line, and line segment, as well talked about properties of line segments. So next thing we're going to do is define a ray. And basically a ray will start in one direction and extend to infinity in the other. So as you see in the picture, like ray AB would look like this, where A is the endpoint. It actually does stop there, but in the other direction, it extends to infinity. And typically, a ray is named by 2 points because we have points A and B. And since A is the endpoint, it will be the first letter written. So this will be ray AB. Ray BA would, I could sketch it above. B would be the endpoint, and then pass through A. So it will look like that. Or you could extend this way. So that first point is the end point of the ray. So once we define a ray, what we're going to do is define an angle. And an angle is the union of two rays with a common endpoint called the vertex. Now, if you remember, our idea of union from sets is basically you would combine the two rays and then all the interior points. That would form the angle. So sometimes they use a set definition to define an angle as the union of two rays. But one of the important things about an angle is it does have a vertex, and this angle would be labeled as angle CAB or angle BAC, but it's named, the middle letter will be the vertex. Covering some basic angles, special types of angles. Let me zoom in a little bit. A 90-degree angle is a right angle. And it looks like in the drawing, it looks like a corner, basically, on if you were to do it, a straight corner, which would be 90 degrees, of course. So that's one of our special angles. You can also have what's called a straight angle, which measures 180. And it will look like a straight line, as you can see. The last part of that next slide will be the special angle pairs, which there are two types of special angle pairs. One is what they call complementary angles. And the key to complementary angles is if their sum is 90, they're complementary. So if you say you had a 60-degree angle and a 30-degree angle, those add up to 90. Those would be an example of two complementary angles. Another definition refers to complementary angles as basically two angles that would add up to be a 90-degree, a right angle. So, alternate definition is two angles whose result, basically their sum, will be a right angle. And a pair of supplementary angles will be two angles whose sum is a straight angle or 180 degrees. Would be supplementary angles. So again, right angle, straight angle, complementary angles, supplementary angles. And that's really it for our special definitions. Very similar idea to the segment addition postulate is the angle addition postulate. So if you have point D lies in the interior of ABC, this angle ABC, and basically you have another ray going through B, that will form two angles that sum up to get the entire angle. So in this situation, the sum of angle ABD plus the angle DBC will be equal to the measure of ABC. So ABC is equal to ABD plus DBC. And that is what we call the angle addition postulate. I will come back to this in a little bit. I want to go back to this idea of supplement and complement. And then we'll do some examples that deal directly with this angle addition postulate. So example 4. The complement, actually I can move it there so you can, if you still need to copy some stuff from the other slide. But anyway, what is the complement of an angle measuring 36 degrees? Well, that basically just answers the question, what angle plus 36 degrees will give you a 90, the complement? And we would just find that by subtracting, which would give me 54 degrees. So 90 minus 36 would be 54 degrees. So 54 is the complement of 36. And when they're complements of each other, they add up to 90. Likewise, the supplement, let's look at that. So example 5, and by the way, these do match up with the PowerPoint notes. But what would be the supplement of an angle measuring 86? Well, in this case, the question is, what angle, I'll use x again, plus 86 degrees is 180 degrees. And again, you could just solve by subtracting, which would give you 94 degrees would be the supplement of 86. And you can check those. 94 plus 86 is 180. So I will go back to doing some examples that involve the segment addition postulate. Again, that is where you have this situation where if you add up ABD's measure plus DBC's measure, you get the entire measure of ABC. Excuse me. Allergies have been really bad lately. Anyway, given that ABC is a right angle, find the value of X, ABD, and DBC. I went out a little bit too much. Let me get that. Looks pretty good. Okay. So, again, we're going to set up an equation and find X, and then from there find the missing angles. So, if we add up X plus 10, that's this angle, ABD, plus the other angle is 3X plus 40, we get 90 will be the sum of those two because they form a right angle. So again, it's just like the segment addition postulate. What we're going to do is just add up and solve for X. So this will be 4X plus 50 is 90. Then isolating X, we would have to subtract 50. Again, do the opposite of adding 50. 4X would equal 40. And then doing the opposite of multiplying by 4 is divide by 4. That gives me X is 10. And then my two missing angles, now that I know X is 10, would be angle measure. Make sure I'm on the page. Measure of ABD would be 10 plus 10 is 20. And then the other one, that should be ABD, pardon me. The other one, DBC, would be 3 times 10 plus 40 would give me 70. 30 plus 40. And those do add up to 90, so it does check. So your final result is your two angles are 20 and 70. Okay, example 7 from the PowerPoint is use the diagram below to find X. So in this case, we just have to find x. So really, it's just a matter of setting up an equation and solving it. So we're just going to do 3x plus 20 plus x plus 20. Now, I really don't say in the problem, but looking at it, you pretty much can assume that is a straight angle, so that will be 180. So we end up getting 4x plus 40 is 180 by adding all your like terms. Again, subtract 40 gives me 4x is 140. And then if we divide by 4, we get, I believe that comes out to 35. Yeah, it does. And that is our, I went off the page, hold on. So your answer would be 35. Okay, the last example of this video will be number 8 from the PowerPoint. Again, we're staying with this idea of segment addition postulate. And we're going to do this example. So, given that ABC is 116, find the value of x, ABD, and DBC again. So, let's set up the equation first. So the sum of these two angles should be 116, the measure of ABC. So this will be 2x plus 6 plus 4x plus 14 is 116. And that's my equation. And then 6x plus 20, if we combine like terms, it gives me 116. Subtracting 20 from both sides, the opposite of adding 20 gives me 6x is 96. And the opposite of multiplying by 6 is, again, to divide by 6. So we get 96 divided by 6 is 16. So the value of x is 16. And then your two angles ABD and DBC will be as follows. And I got to slide this over so you can see it. Will be 2 times 16 plus 6 is 32 plus 6 is 38 degrees. Well, I'm going to have to zoom out here. Hopefully you can be large enough to see that. Okay, and then the last one will be 4 times 16 plus 14. So 4 times 16 plus 14 will be 64 plus 14 is 78. And yes, those do add up to 116. So that does check. So your answer is x is 16, and then your two angles are 38 and 78. That pretty much covers the whole PowerPoint. All the definitions, all the things on angles and segments and definitions, again, are covered in the two videos. So the next two videos coming out will be on volume, or excuse me, area and volume, then proportions, and then Pythagorean theorem. So just continue the work on the geometry unit, and the next video will be on area.